So now that we know all about these two new classes, let's get back to the task at hand, which is setting up the size of the universe. Now what we're doing here is we are basically creating a B2 AABB that defines the size of the world that we care about. We're basically telling Box2D if an object falls outside of these bounds, I no longer care about it. It's probably an object that I just lost track of, and rather than have it fall forever into infinity, once it hits the bounds of the universe, you can kind of stop it. And that's good. Once an object falls outside the bounds of the universe, it's kind of hard to do anything with it. I think it's still in memory, but I have trouble getting them to work again. So you want this to be big. You want this to be much larger than just, say the bounds of what you're going to see on screen. And generally, I'd say err on the size of being too large than too small. Let's say we want our size of the universe to be from -3,000 pixels all the way to 3,000 pixels. That'll give us a universe that's 6,000 pixels wide, 6,000 pixels high. That's probably good. So let's start. I'm going to have a universe size, and it's going to be a B2 AABB class. Now when we create this B2 AABB class, it's going to create a lower bounds and upper bounds point, or really B2 vec, by default, both of which are set to 0, 0. We obviously want to set that to whatever our new bounds are. So I'm going to type universe size dot lower bound, and because it's already B2 vec2, I'm going to type dot set. And this is that set function I mentioned earlier, where you're able to define the x and y coordinates at the same time. So we'll go -3,000, -3,000, and it'll have universe size upper bound set. And if I can type, we'll have +3,000, +3,000. So we've defined the size of the universe, right? Well, no, not exactly. The problem is we have defined this object that's 6,000 by 6,000, but it's actually not what you're expecting. It's not 6,000 by 6,000 pixels. And to find out more, let's find out a little about units.